Okay. Hello everyone, my name is Srihari and today I'll be sharing with you 3 points which are going to save you tons and tons of hours while you're doing CAD. Now, honestly, I myself do CAD because it is required in my course and also because some part of me also likes CAD. But I'm not so good at it that I'm able to flawlessly create out newer parts and that with high accuracy. And of course, I make mistakes, but hey, mistakes are something that are to be learned from. And through this video, I'm gonna be sharing some of the learnings, some of the mistakes I make, some of the learnings which I have learned so that you'll be able to implement them in your own workflow and hopefully improve your productivity and manage your time better while using these very useful but complex CAD softwares. Without further ado, let's get into the video. So the first point which I want to share with you is the importance of using engineering drawings or basic sketches. I hope you know this. This is an engineering drawing sheet, and this is just one example of many physical forms of writing or physical forms of sketches which you can refer and make 3D parts out of them by using the CAD software. Now, why did I show you this engineering drawing sheet? Well, when you first get the 3D software, many of you will have the notion that now from now on we'll not do the designing on paper, but instead we'll do the designing on entire 2D as well as 3D designing on CAD itself, on the CAD software itself. Let me tell you that you are not well adapted to the CAD software. Okay, so it will take time for you to adapt, and even if you did, uh, the very preliminary sketches, right? If you're trying to do it on CAD, and then you're slowly building up on the design using the CAD software, it becomes a very tedious task. Okay, the task which is supposed to take like 1 or 2 days of time, it's gonna take you a week or two or even more. Okay, depending on how complex your project is. And in that case, using a CAD software for developing a preliminary design is not at all recommended. In fact, no one does that also. Even if you look at the professionals, you might think they are using the CAD software for 2D and 3D drafting also. You are half right over there, but none of them actually use it for the preliminary sketches, not at least at the very first stage. While we are actually deciding on the fundamental design of your part or some model which you want to develop. The general process is that instead of first starting out on CAD directly, they would usually sit down, take a piece of paper, and try to sketch out. Okay, this is important. They try to sketch out the fundamental design of the model. Okay, they try to decide on how the functionality is affected, how its ergonomics will be affected, what will be its average size, what should be the most comfortable posture while holding it, or what's the most easiest way to handle the material or handle the equipment. Okay, all these factors are decided while we are doing the sketches part, and it is generally done in the sketches part because we have more control over the variables over here. Okay, as compared to a CAD software, and in a process such as design where you require more focus, where a lot of thought process is going on, you would not like to get derailed by factors such as loss of control. That just beats the whole point of having a CAD software. So, usually you would always find CAD professionals who they always start out with the preliminary sketch on a piece of paper. From that, they take it to the CAD software, and in the CAD software, they will develop the rough 3D model, and they'll get a rough idea on how the product will look like. Based on that, they will, since they get the feedback from that model, then they'll make certain corrections and then improve on. Okay, that's how the process goes. You do not just directly jump onto the CAD software and then start designing your required model, and just break your head as to why am I not getting any ideas. it will happen with you. Okay, trust me, it will happen. I have been in that place. I know it will happen. So it is always recommended that you start out on a piece of paper, design your part over there, then take it to the CAD software. Then you can make further improvements. And another thing which I'd like to add over here is, say that you're designing some handheld product or some small product. Okay, in that case, developing a one is to one scale sketch. Okay, or one is to one scale of your engineering drawing for the required model which you're trying to develop, that would be actually be very helpful, because in that case you'll have proper idea of how the final product will look like, how the actual final product will look like. Whereas if you're trying to do the same in the CAD software, um, usually what happens is that when you're trying to optimize your material, or you're trying to optimize the dimensions of your parts, that time you'll face problems on deciding on how how wide your material should be, or how much clearance should be given on the material. Because in the CAD software what happens is that you have so much you have so much and so much amount of required control over there on each and every variable, that say that you gave a clearance of 0.1 mm. Okay, if you are trying to do that on a piece of paper, you'll probably understand that zero point 0.1 mm clearance might be enough. Okay, if you're experienced that much, you'll be able to understand it just by looking at the sketch itself. But if you're trying to do that on the CAD software, say you give a zero point 0.1 mm clearance, next thing is you will start judging yourself whether I gave a little bit more clearance or I gave a little bit less clearance. Maybe I have not done it right. Then you try to zoom into that one area where you have given the clearance, and the next thing you know is that you suddenly find that clearance is too much. Okay, you suddenly find the clearance will be way too much, and then you'll be like, I have to reduce the clearance a bit more. And you go on doing this process until you reach a point where you can no longer compress it. But even then the end result would be that the clearance will not have turned out properly. While you try to fabricate that in the real life, you will not get the proper result what you have expected for. Okay. Similarly, it goes with the thickness of the material, or while you're doing material optimization also. So that is why it is always preferred that you do the preliminary sketches, preliminary design of your part on a piece of paper. Okay. The second point which I want to mention to you is about the use of global variables. Now, say that you have created a model, or you have created some part using the design sheet, and say that you have to modify this part because you thought maybe this part will be used for different applications, so we'll have to modify it accordingly. Now, if it has many such features which needs to be changed, then chances are you have to go back in the editing timeline, modify each and every feature. And if this is one or two features, it's okay. It will not take that much time. But say there are many such features, okay, and especially if these features are interdependent on each other, then it becomes very difficult to edit, because chances are that you'll run into some error while you're in the updation process, and you'll have a hard time coming out of that error itself. You will have a hard time solving that error, then once again updating, then chances are you'll run into another error. So in such cases, use of global variables is very much preferred. Okay, especially if in the cases when your part is being modified continuously, or your part is being subjected to changes in a continuous manner. Earlier on, when I used to do CAD, I simply used to dimension out certain features of the sketch, and continue on with the modeling process. It did not make much difference to me. But later on, while I had to modify some parameters of my design, I usually used to run into some error, and solving that error itself used to take me a lot of time. Okay, because uh, as you know, in CAD software, if you're trying to edit some feature, there'll be some other feature or some other sketch which will be dependent on this particular feature. And if the updated values for this particular feature is not under the safe zone, which I'd like to say, or it's not under the proper value or proper range, then the features or the sketches down the line will also get affected. So you'll have a hard time solving them also. Instead, if I use global variables, all I have to do is I have to go to the global variables tab, check on the particular variable which I have to update, just update the variable over there, click on apply, and that's it. There are chances that I'll run into error over there also, but the chances are very minimal because over there I can not only set up the global variables, but I can also set up the relationship for other variables also. Now, say I create one particular feature and a second feature which is based on the first feature. Now I can set global variables for the second feature such that its parameters change on the basis of the first feature. So if I change the first feature as per my requirements, then obviously the second feature it depends on this will also change because its parameters are depending on the first feature, right? So my my whole process of individually going to each feature, updating them as per my requirements goes down dramatically, and this saves me a lot of time as well. And that's why I suggest you that when you're trying to develop new designs, or when you're trying to develop any designs for that matter, use global variables. That way the updation process later on will become much more easier. And now let's move to the last but not least point of this whole video. Okay, so to explain you the third point, it was necessary to bring up this engineering drawing. Some of might already recognize this. Yes, this is from the SolidWorks certification exam. I thought this is good enough to explain my point, so here it is. So the point which I want to mention over here is, do not make your own equations. Okay, at least even if you're trying to make equation, make sure that you mention them in the global variables space. But if you're trying to make your own equations and for implementing certain dimensions, like for example, let me give an example over here. Look at this length. This is 25, right? This extrusion is 25. So this length from the base to the top face over here, that measures 25 mm. Fine. Now here we have another extrusion which is measured at 35 mm. That is this part. This part will be measured at 35 mm from the base. Okay. So both are referencing the base. Now one mistake what you could do over here while modeling is that say that you could extrude this part up to 25 and then take this top plane as the reference and extrude 35 minus 25. Okay, even in both cases you'll get the values. Okay, you'll get the model right, but later on while you're trying to update your design, what are you referring? You're referring these engineering drawings over here. There's no space for 10 over here, okay, or any other value which you created by using your own equation. So if I update this any of these values, then there are chances that this variable might not get updated. In fact, there's a very high chance that will not get updated. And in that case, uh, obviously you'll end up with the faulty model. And that is why it is very necessary that while you're modeling out any part, use the dimensions whatever they have given. Okay, do not try to make your own equations. Now another way of creating the same part over here was, instead of referencing the top plane, you could have referenced the bottom plane, like extrude from the bottom part, extrude from here and take it up to 35. Could have done that. Okay. The benefit of this being that any updation you create for the engineering drawing sheet, or any updation you create for the model, say I update this variable, I update this variable, or I update any variable for that matter, that can be immediately updated in the model itself, because you know which variable you have to look for, which variable has to be updated to what value. Okay. Instead, if you're going down the wrong path, that is creating your own equations, or creating an over analogy of the model and creating out new numbers, then it will be very hard to keep track of each and every number over there. And that makes the whole process of updation a lot more difficult. Forget updation, I am pretty sure that you'll not be able to even finish modeling the part, because it'll get difficult. Okay. uh, when I tried to model this part first, I was given 45 minutes of time and I could not finish like even half the model in 45 minutes. You know why? Because one thing was that I was not using global variables at that point, because I was new to SolidWorks. But secondly, I was trying to do that analogy of 35 minus 25 everywhere over here. So later on, the second questions, the progressive ones, included updation for the variables over here. When they asked for updation, then I had no clue. Okay, earlier on itself I had very much difficulty of creating the model. Later on when they asked for updation, I was blank, like I could not figure out how to continue forward in the model. And that led to me not able to finish the entire model itself, and I had to give up halfway. So learn from my mistakes. You are not me. Do not do your own analogy of creating new numbers out of the blue over here. Use the same numbers that are given over here, but try to use them as they are given. Do not use new numbers, and reference them in the same way as mentioned in the drawing. Okay, that will save you a lot more time. All right, I think now it's time to sum up the points I mentioned in the throughout, which I mentioned throughout the video. So, first thing, make sure that you get your preliminary sketch or fundamental sketch down on a piece of paper. Don't just directly jump onto CAD. Secondly, use global variables. Saves a lot of time for you. And the third point being that do not bring up your own numbers. Use the numbers that are given in the drawing sheet itself or in the engineering sheet itself. If you try to bring up your own numbers, then you'll have a lot of hard time keeping track of each and every one, and it makes the updation process a lot more difficult. And yeah, I hope you learned a lot from my mistakes, and I hope you'll be able to implement this. If you have any more doubts, just put it down in the comments. I'll try my best to help you. If not, I'll refer to my seniors. I'll refer to whomever I knew who is well versed in this field, and I'll come back to you and help you out. And with that note, I'd like to end this video. Thank you.